Wait, actually, don't be quiet. You're already annoyingly too quiet. But today's a lab. I'm just recording the introduction to the lab, so it's not that big a deal. It's called Bottle Bewilderment on page number 7. It's one of my top 25 labs of the year. She's right. But I actually love this lab, but you guys always say you say that every time. This is a good thinker. So you'll have an instruction sheet. Please pick it over by the yellow piece of, or the yellow folder. You cannot do this lab without the instruction sheet. So here we go. The instruction sheet will tell you all of this stuff. So the first thing I want you to know is that this lab has some toxic waste that we make, literally. So you cannot put anything down the sink today. It all has to go into the garbage. Raise your hands if you heard what I just said. Okay, so you will take your microwell plate full of colorful liquids. You'll dump it into the garbage. Then you will wipe all the liquid off of the microwell plate and then go wash it. You okay with that? It's pretty strict. I am not allowed to put lead and mercury into the wastewater system. All right, so here we go. Imagine you are a chemistry teacher, which isn't as bad as it sounds. You've just made up 6 solutions, placing them in bottles labeled A through F. Those bottles are over there in that tray. They are these things. So these things are your reactants today. So they would belong where in a reaction? Tell your lab partner, the left or the right? I heard one group say the word left, and that's correct. Left is where your reactants go. Your reactants react to form products. These right here today will be your products. These products will come from a reaction from those to become these. All right? When you do this lab, it's actually pretty cool and very colorful. Now, all these solutions are colorless. By the end of the day, liquid A turns, but who cares? So it's just a little bit colored, but the rest of them are completely colorless. Hello, young man. Let me get you a note. How did it go? Okay, here we go. So, once again, yikes, you forgot to do one thing. You did not write down which solution was placed in each bottle. Panic-stricken, you desperately try to remember what you did, but to no avail. You do, however, remember that bottle A is Ki. So right here, where it says bottle A, will you put Ki, capital K, capital I. And then I would also encourage you, this will help you to figure stuff out soon, I would put Ki right here as well. Because we're just going to use some logic to figure everything else out. Logic and some chemistry. All right, so you should have Ki here. You should have Ki right there as well. All right, back to the instructions. Then suddenly you realize that you are a pretty tricky chemistry teacher. Since your class had just finished a unit on equation writing, I decided to shift the burden to them. Knowing all these solutions are colorless and tasting is out of the question, you will probably need to investigate how these solutions react with each other. Since you are a rather intelligent person, you know that each chemical will produce a colored precipitate when mixed with each other in the proper manner. So this is our goal today, is to find these colors. And if we know what the colors are made out of, then we know what needs to make the things the colors are made out of. All right, that sounds weird, but it's pretty easy logic. So, for instance, here we go. Everything I'm going to write in this box is wrong right now, so do not copy anything I put. Is that clear? Okay, so let's pretend we mix A and B and it goes orange. All right, based on my instruction sheet, orange comes from HgI2. So if it had turned orange, I would have written orange, and I would have also written HgI2. Now, so this is essentially a party, and Hg and I2 are now dancing. Well, bottle A brought the I. That means bottle B must have brought what? Hg. It had to come there somehow, right? So we know B has Hg in it because the combination made HgI2. So I go back to the top and I find Hg right there. And so if this turned orange, that would mean that bottle B was HgI2, or sorry, HgCl2. HgCl2. So the combination of A and B, oh boy, whatever, HgCl2 plus AgI makes the thing that turned orange. Ag, sorry, yeah, whatever. I want Hg first. I2, that's my orange. Plus the other pieces have to be accounted for, so it would be AgCl. That would be the reaction I would write on the bottom of the page, on the 1 through 5. Now, a couple of quick things. When you are writing these out today, please remember that this 2 belongs to Hg's partner because it was a +2. It does not belong to the Cl. I did not put a 2 here because there isn't one. I put a 2 there because the 2 belongs to Hg's partner. The 2 belongs to Hg's partner. So this would be not there. Okay, then on the bottom, I just did one of these, but these things are the names of the products. So like right now, for number 1, go ahead and write it. It's lead 2 iodide, which is PbI2, plus some other stuff. Next, number 2 is silver iodide, AgI, plus whatever. Third one, silver hydroxide, AgOH, plus yada, yada, yada. The things that are over here will be discovered using your lab to find the colors and then identify what's in each bottle. Now, this is a tricky lab. You have to think it through, but if you're very logical, you have an advantage over those that are not logical. All right, now, safety glasses today. Don't put the waste in the sink. And then also, there is a chemical today that may stain your skin a little bit. It will look white for a while. I have some on me on accident. But after I go into the sun, it's going to turn pretty black. It will stain you, and it can stain jewelry. That's why Danielle just took her ring off, right? Sure. So make sure you wash your hands with water when you're done. I don't know. Oh, 2 things. On the instruction sheet, it's going to tell you there are things that go yellow and grello, greenish yellow. You will know which one is which when you've made both of them. So make the first 4 or 5, and the grello and the yellow are in that group. Then, as far as brown and gold are concerned, if you do this in a logical way, meaning sort of from left to right in some sort of order, you will get brown before you get gold. So if you just kind of work your way over and down, you'll get brown before you ever get gold. So your first one that you're wondering, is it brown or gold? That's your brown one. And then the very last one that changes color is the one that's gold. And today it's been more yellow than gold for some reason, but whatever. It's not the first, it's towards the very end. Okay, safety glasses on, wash your hands, waste in the garbage, have a good time. Okay, so I've put on the data here. So this word says orange, by the way. So now what we would do, we use our logic skills and the instruction sheet that you can look at if you click on the other link to figure out what happened here. So if we have grello, which is greenish yellow, that means that bottle A and B made AgI. All right, so Potassium iodide is where the iodine came from. But bottle B must have been the thing that had the Ag. So we would look at the instruction sheet at the top, and we would see that Ag came with AgNO3. Okay, so then we have silver iodide. So I'd come over here on the bottom now. Silver iodide is right here. I know it's making AgI. I just said it's between bottle A and B. So I just take the things and put them together. Ki plus AgNO3 goes to AgI, but I have to include the other parts. The leftover pieces are KNO3. And I'm going to do that for each one. I won't do much more. But yellow came from PbI2. So the I came from A. C must have brought Pb. So I come over here. Here is my lead. So I have to write that entire thing. So C is PbC2H3O2. 2. And I would put that here, right there. All that stuff I'm not going to write. Anyway, that's the process we go to identify what the types are. And then once we know what they are, we write the precipitate forming reactions for each thing given. Okay, good luck. Once again, you'll need that sheet that is linked right there on that same page you were on to get here.